Theorem 6.1. But before we understand the theorem, let us recall the definition of a mathematical proof from Appendix 1. It says, a process which can establish the truth of a mathematical statement based purely on logical arguments is called a mathematical proof. We must emphasize on the words logical arguments. So our arguments should be logical to prove the theorem. Let us recall from Appendix 1 the ingredients of a proof. To prove any theorem, we should have a rough idea as to how to proceed. But how can we have a rough idea? We can have a rough idea from the information already given to us in a theorem. The information already given to us in a theorem, which is the hypothesis, has to be clearly understood and used. We call it given in the statement. So we have to understand the information already given in the statement. Next, a proof is made up of successive sequence of mathematical statements. Each statement in a proof is logically deduced from a previous statement in the proof, or from a theorem proved earlier, or an axiom, or our hypothesis. So each statement that we are going to write in a theorem has to come either from our previous above statements, so that it is following a logical order, or it could be because of a theorem which we have already proved earlier, or an axiom which we already have studied, or our hypothesis given in the statement. The conclusion of a sequence of mathematically true statements laid out in a logically correct order should be what we wanted to prove. That is what the theorem claims. That means the sequence of the logically correct statements we have used should lead us to prove the theorem, not to prove something else. Let us now examine the case when two lines intersect each other. So as you can see in the figure, when two lines intersect each other, there are four angles formed. Recall from earlier classes that when two lines intersect, the vertically opposite angles are equal. Let us prove this result now. Recall from earlier classes that when two lines intersect, the vertically opposite angles are equal. Let us prove this result now. So we are going to prove in this theorem 6.1 that if two lines intersect each other, then the vertically opposite angles are equal. Let us understand what is already given to us in the statement. In the above statement, it is given that the two lines intersect each other. So let AB and CD be two lines intersecting at O as shown in figure 6.8. They lead us to two pairs of vertically opposite angles, namely angle AOC, as you can see here on the figure, it's coloring, and angle BOD. They both are vertically opposite angles, and angle AOD and angle BOC are the other pair of vertically opposite angles. We need to prove that angle AOC is equal to angle BOD and angle AOD is equal to angle BOC. Now that we have understood that what is given to us and what we need to prove, let us think of our logical arguments. Now, ray OA stands on line CD. As you can see in the figure, on line CD, ray OA is standing on it, and so we get two pairs of adjacent angles, angle 1 and angle 2. Therefore, can we say that angle AOC, which is angle 1, plus angle AOD, which is angle 2, is equal to 180 degree? Yes, because according to the linear pair axiom 1, if a ray stands on a line, then the adjacent angles so formed make 180 degree. So using this axiom as our reasoning, we are going to put this statement as our result 1. Now, can we write that angle AOD plus angle BOD is equal to 180 degree? Let us look at these two angles in figure here. Angle AOD, that was angle 2, and angle BOD, let us call this angle 3. Are they both equal to 180 degree as well? Yes, if we consider ray OD standing on line AB. Yes, according to linear pair axiom 1, we can say that angle AOD plus angle BOD is also equal to 180 degree, and that will be our result 2. Euclid's axiom 1, if you remember from chapter number 5, it says that things which are equal to the same thing are equal to one another. So if we look at our result 1 and 2, in result 1, we have angle AOC plus angle AOD equal to 180 degree. In result 2, we have angle AOD plus angle BOD is equal to 180 degree. So both of them are equal to 180 degree. So using this axiom as our reasoning, we can say that angle AOC plus angle AOD is equal to angle AOD plus angle BOD. So from 1 and 2, we can write that angle AOC plus angle AOD is equal to angle AOD plus angle BOD. Now, we need to prove that angle AOC, remember the statement that we need to prove is angle AOC should be equal to angle BOD. So we need to prove that AOC is equal to BOD here. So we need to remove AOD and AOD from both the sides. So let's see how we can remove it. Subtracting angle AOD from both sides. So I'm going to subtract AOD from left hand side and also angle AOD from right hand side. What will happen? Positive AOD and negative AOD will cancel out here. And again, positive angle AOD and negative angle AOD will cancel out here. So which axiom have I used? I have used Euclid's axiom 3. When equals are subtracted from equals, the remainders are equal. So now what is the remainder? Angle AOC is equal to angle BOD. That is the remainder. So I have proved that the vertically opposite angles, one pair of vertically opposite angle is equal. Now similarly, we can also prove that the other pair is equal. Similarly, it can be proved that angle AOD is equal to angle BOC. We need not write statements to prove it again. Writing this statement is enough. So that's theorem 6.1.